Welcome everybody. In this video we are going to talk about conditionals. Conditionals are a way of sometimes executing certain lines of code or certain blocks of code. So a couple of pieces of review from the last video. Number one, make sure that all of your Python files have this header at the top where you say the name, who wrote it, which is going to be you, and when it was last updated. Please remember, give all of your files, all of your variables, all of your projects descriptive names, and create a new Python file for this video. Call it conditionals1.py. So you can see here I've done my outline in comments, which is a good way of working through these things. And so, one of the things I talked about in the last video is eventually we're going to get to a point where we're thinking of programs less as a series of instructions that are executed by the computer, and a little bit more as creating and manipulating conceptual objects. But they are, on the very basic level, on the most basic level, programs are a series of instructions that are executed by the computer. And generally, this is going to be review for you, but generally when you run a program, the computer goes line by line and does exactly what you say on every line in the order from the beginning of the code to the end of the code. Sometimes, though, you may want to have sections of code that don't always execute. The way you do this is with conditionals, and the most basic conditional is an if statement. So let's get a couple of variables declared, and then let's see the basic mechanics of how an if statement works. So I'm going to create a variable called number to test, and I am going to say that it's equal to 7. And so let's say that I've got a program and I'm taking input in some form from the user. Maybe I'm prompting them using the input function. Maybe there's some other way they're getting input using a mouse or a joystick or something like that. And I need to, they give me a number in some form, and I need to test and see if it's above a certain value. So the most basic form of if is if, and then something that evaluates to a Boolean. And I'm going to write, if number to test is greater than 10. So this is a deceptively simple 2 lines of code that conceals a lot of more complicated things that are going on. So the first thing I said is I need some statement that evaluates to a Boolean. Now, number to test is greater than 10 is a statement. You can look at this and say, is this true or false, right? Is 7 greater than 10? No, that's false. So this is going to evaluate to false. You'll notice I have a colon here, which I use to introduce a block of code. And you'll notice that I've got an indent here. So one of the big differences between Python and other languages is that in Python, there are many situations in which whitespace and indentation matter. So when I have a code block, which means that I'm using a colon to introduce some group of code, you indicate what belongs to the code block by tabbing it in. So everything I tab in after this if statement is going to execute if the if statement evaluates to true. If I put something, if I tab back in, and you can reverse tab by holding down Shift and hitting Tab. So that's no longer in the if statement because it's lined up back here. If you have multiple if statements nested, you'll need to indent it an additional time for each if statement. We'll talk about how that works a little bit later. So when I run this program, it's just going to say this line will always print because 7 is not greater than 10. If I change it to a number that is greater than 10, like 11, and I run this, I'm going to get this number is above 10. It's going to print this. This will execute as well, but only if the statement evaluates to true. And then it's going to print this line will always print. So this is demonstrating that when number to test is greater than 10, because I set this little condition up, the stuff inside of this if statement. So it's indented, right? Physically, it is indented, but conceptually, it's inside of the statement. You'll hear me saying this is inside of the if statement. What that means is this code belongs to the code block that executes if the if statement evaluates to true. So a couple of things a little detour I want to take before we move on to if-else statements is I want to show you, number one, how to use the Python console. If you go down here into the left corner, you'll see a little icon. This is supposed to be two snakes. It may or may not look like that to you. That's the intent of it. That's the Python logo. If I click on this, it brings up a little dynamic, a little execution environment where I can write Python code and have it execute immediately. So I'm going to make this a little bit bigger so that we can see a little bit more of it. And I am going to do a couple of things in here to show you how this works. I'm also going to introduce a new concept called casting. So casting is actually a pretty big concept. I'm going to add this into my little notes here up there, just so that we've got it on the screen as an outline. Okay, so I'm going to recreate my number to test down here. And you can see that when I create the variable, it gets added to a little list over here that shows me what I'm working with. It shows me what objects I've created, shows me what type they are, and it shows me what value they have. So I can also rewrite the same if statement. And you'll notice it indents it for me, and it gives me this little ... colon. I hit enter. I have to shift tab and hit enter again to tell it that I'm ending my little if statement. You'll notice it executes the if statement after I type it. It says the number is greater than 10. So one of the types of variables that we talked about in the previous video is called a bool. So I'm going to create a bool called is statement true, and I'm going to set it to false, just to give it a value. And you can see if I don't give it a value, I can't create it as a bool. I want to create this as a bool, so I do that. And so I can say something like is statement true equals, and this is going to look really weird, number to test is greater than 10. So I want you to think in your head what is statement true is going to have in it after I execute this line of code. So you'll notice now it has true. So the reason this works is because number to test is greater than 10 is a statement that evaluates to either true or false. I can actually just write this down, and it'll show me true. It'll show me that this evaluates to true. If I do this in my program, it won't work that way. I'd have to print it out. But because this little Python console is designed to do testing, it just shows me what the output is. So when you are writing a if statement, what I want you to think is this thing in here has to evaluate to true in order for the code in the if statement to run. It's a little bit more complex than you've had in your previous programming classes, and I'll show you why that matters. So a frequent thing you will see programmers do is something like this. So I didn't say any condition here. I just said if number to test. And if that evaluates to true, I print out why does this work. So this tells you that if I say if number to test, it's going to evaluate number to test as true and then print out why does it work. So what it does when you just give it a single variable is it does internally what's called casting. Casting means when you force one variable type to be another or you convert it to another. This is super duper useful. If you completed the coding challenge in the previous video, you will know that input always brings in as a string, for example. And if you need to do math, if you're asking somebody for a number on the Python console and you need to do math with it, you can't really do math with a string. You have to convert it to an int. And so you do something called casting. So the way casting works is you say the variable type, and then you put the variable you want to convert to that variable type in parentheses. So if I get out of there, if I do bool number to test, it's going to show you that the variable number to test when you convert it to a bool is a true. That is why if number to test runs the code inside of the if statement, because what's going on here is it's converting this to a Boolean under the hood. Since the Boolean is true, it's the line of code ends up running as if true, which is true. It executes the code. The only integer that evaluates to false is a 0, right? So if I have is statement true, number to test equals 0, and I do the same thing, so I'm hitting the up key to get my old code back. If I run this again, it doesn't print anything out, right? I can double check this behavior by saying bool number to get out of here. Yeah, I hit escape to get rid of, if the IDE throws up a bunch of stuff and I don't want to see it, I hit escape. It's false. So this right here, where you just say if and then you just give it a variable name, usually is used to check if something is initialized or exists. A none type will also always evaluate to false, right? So I could say, and then I could say bool, and this is just going to tell me, does this evaluate to true or false? Evaluates to false. It's another good way of checking to see if variables are initialized when you get more complicated programs going on. Okay, so this was a little detour. I want you all, before you move on with this video, I want you to get in the Python console and play around with this concept. I want you to, number one, get used to using the Python console down here. It's one of the more advanced tools we're going to be using this semester, or this year, and being able to inspect the language and figure out how something works is a really valuable strategy for moving forward as a programmer without having to rely on always going to Google or always having somebody help you. You don't understand some behavior in the language, your first instinct should be to go to the Python console and see if you can figure it out. A lot of times you can't. A lot of times it's either too complex or there's something you're missing, but a lot of times you can. Okay, so I'm going to go ahead and, again, put this stuff in before you move on with the video, play around with it some. We're going to go ahead and close the Python console and go back to our code. Okay, so that was a very, very long detour to say this right here is being evaluated. It comes out as either true or false in every case. You can cast, I believe you can cast anything to a Boolean, and any statement like this is gonna evaluate to true or false. So we talked about variable casting. If you want to cast to other variables, you can cast a string, you can cast to int, you can cast to bool. You can't cast to a none type. There's some types you can't cast to. I believe you can cast to a float. I'm not 100% sure on that. If I wanted to figure it out, I'd go to the Python console and try it out. But variable casting is a really, really valuable tool for making sure you're working with the right type of data. You will use it a lot when you're getting input and when you need to change a string to a number, so you can do math on it, and then change a number back to a string so you can print it out. Okay, so let's get a little bit fancier with our if statements. So let's say I want to see if a number is between 10 and 20. So I'm gonna have other number is equal to 15, and I want to have a little line of code that tells me if the number is between 10 and 20. So I am going to say if number to test is greater than 10. Let's do this. It's less than 10. I'm going to print this number is less than 10. Else, and then I'm going to say else this number is greater than 10. This is a little bit different than what I described. So what this line of code is doing is saying, is the number less than 10 or is it greater than 10? So when I run this, think in your head what's going to happen. So it's got the code from up here. This is still printing out. This number is greater than 10. This is still executing. And down here, if number to test is less than 10, it says this number is greater than 10. So the way this works is this else is attached to this if statement. So the if statement says, hey, if this evaluates to true, then do this. The else statement says, in any other case, which means if it evaluates to false, do what's under the else statement. So the else is a sort of catch-all at the end of an if statement. You can only have the else attaches to a single if, and you can only have one if per else. You can't have two else statements attached to an if, and you can't have an else statement attached to two ifs. So if I did something like this, this else statement is now attached to this if statement. So we're going to say, what is going on here? So when I run this, and I'm going to comment this stuff out. Another use of comments is just to disable code. I'm just going to comment all this stuff out so I don't have to see it every time I run it. So I'm going to run this, and it's going to say this number is greater than 10 because this hits. Now, if I make this number less than 10, I want you to think in your head what's going to happen before I run this. I'm going to give you a beat. I'm going to run it. And it is going to say this number is greater than 10. That seems wrong to me. It's because I'm not testing the right number. Wasn't paying attention to what I was doing. This is a common thing that you'll do. You'll write something, you'll think it does one thing, you'll play around with it, you'll realize something is going on. A quick look at the code revealed that I was doing that incorrectly. You may have actually noticed that before I did if you're paying attention to the video. Okay, so let's run this again. So it's going to say this number is less than 10. It is then going to go into this separate if statement. So this one executes out. This is real simple. Then goes into this separate if statement and says, okay, is it greater than 10? It is not. So then it goes to this else. But what is important here is this else is only attached to this if statement. This if statement is by itself. So an else only attaches to one if statement. One else per if statement, one if statement per else. Else is a good catch-all if you're testing to see if something is a number of different things. A lot of times you'll need an else at the end to say, okay, this is something different. Or here's what we do if none of these things are the case. Okay, so there's another way to, if that's not confusing enough, this is one of the places where you start to have to really think through the logic of what you're doing. There's another way of chaining these things up. So let's say I have a number, and I want to figure out, is it between 10 and 20, 20 and 30, 30 and 40, etc. So there's no way to do that, right? And you can see pretty clearly that an if and else only gives you two options, right? You can't tell if you have like three or four different criteria you're trying to figure out if it meets. You cannot do that with an if else. Now you could do something like a bunch of different if statements, right? The challenge there is you need to make sure that all of your if statements are mutually exclusive. So if you want to try and figure out what range a number is in, it's very difficult to do that with just if statements. I'm actually not sure if you can. But let's say that we've got a student grade. And let's say that we're not at Cassidy. Let's say that we're at one of the many, many other high schools or universities or grade schools in the nation that has a 10-point grading scale. So we're going to, what the letter grade is, based on the number grade, based on the number. Let's say we want to do that. We want to make a little if statement that prints out the letter grade based on this. So here's how we would do that. So I'm going to say if student grade is less than 60. Oh, and you don't need these parentheses in that. That's a C++ thing. In Python, there's no parentheses. I will sometimes forget and put them in there. Ignore it when I do it. Okay, so if the student grade is less than 60, the student has an F. Let's try and do this in the naive way with just the if statements. So if it's less than 70, has a D. So I'm not going to finish this out because it's not going to work. You may have already thought in your head why this isn't going to work. Other thing I'm going to do is comment out some of this code up here. comment out all these lines so we don't have to see it. So I'm going to run this, and it's complaining about the indentation there. You can ignore that. I'm going to run this, and the student grade is less than 80, so it prints out the student has a C. But what if my grade is a 60? Says the student has a D and the student has a C. What if my grade's a 50? So what's going on here? What's going on here is all of these are being evaluated independently. So is 50 less than 60? Yes, we've got an F. Is 50 less than 70? Yes, we've got a D. Is 50 less than 80? Yes, we've got a C. So obviously that's not going to work. One way to get around this is to use elifs. So let's say we want to do this. Let's say if it is less than 60, they have an F. Otherwise, elif, which means if this if doesn't hit, let's test something else. So if it's not less than 60, which means it must be greater than 60, right? If it's not less than 60, it must be 60 or greater. So let's say, okay, what if it's less than 70? Then we can print out the student has a D. And you can chain these together. So let's say, oh wait, okay, what if it's less than 80? And we're only going to get here if none of these have hit, right? So we know it's 70 or above. So the question is it 80 or below? And so now this is going to work correctly. So if I run this, 50 gives me an F. Let's do 61. Gives me a D. And let's say 78 gives me a C. Now I can have one else at the end of this. You can't, again, you can only ever have one else. Else's do not take a condition. And they're at the end of, so these are all chained together, right? It's best to think of this as a logic chain. Up here, these two are separate. These two, the if and the else, are chained together. This is one big chain. This is just going to say the student did better than a C. So I'm going to run this. Currently, it's just going to say I have a C, but let's say I got an 84. I run this, and it just says I did better than a C. Because above an 80, at 80 or above, actually, I should say, this does not. So you can include it equals doing that. This doesn't do that. At an 80 or above, I have better than a C. It's just going to say that. So this is, yeah, I just put this in the wrong little section. I like to keep my code organized. That's something I would strongly recommend you do as well. So we're just going to organize that there. Okay, so that is the basics of if statements, of if-else statements. And I'm going to uncomment this code just so it doesn't look quite that bad on here. It's a lot easier to comment code than uncomment it. Let's see, what are we complaining about? I think it's because my indentation is wrong. Python is really prickly about indentation. If you do it wrong, it will give you errors. I don't think this is an error. I think that this is just, let's see. Yeah, unexpected indent. Okay. It is because this is indented. Yeah, like I said, Python is very prickly about indentation. If you comment and then uncomment, sometimes you can have that happen. There's a different way to comment blocks. We'll cover that at some other point, but right now I'm just going to... Oh, that's a real comment. These are real comments. Okay, so this is where we should be. So, to review what we covered in this video so far, we talked about the basics of an if statement, which is if followed by something that evaluates to a Boolean, followed by a colon, followed by an indented code block. And all the indented code block belongs to the if statement. I call that it's inside the if statement. You can add an else to an if statement, which executes when the if statement is not true. And you can chain if, elif, and else. You can have an arbitrary number of these elif statements, and you don't have to have an else. If you have an if, that's good enough. If you have an elif, you must have an if before it. If you have an else, you must have an elif or an if before it. One else per if, one if per else, or one if chain, I should really say, per else. But you can chain as many of these elifs together as you want. There are some other things to know about conditionals, but this video has gotten a little bit long, so I'm actually going to put those in the next video. I'll move that over into a code thing called Conditionals 2. For your skills check, I want you to finish this out. So I want you to take this little snippet of code that does student grade evaluation and says, is it an F, is it a D, is it a C? I want you to finish it out, and I want you to change the numbers for Cassidy. So I'll do the skills check right up here. This is a skills check, by the way, not a coding challenge. You still need to upload it to my Cassidy. You need to upload the Python file, but this is the smaller of the two assignments. Actually, I'm going to add a little bit. So I want you to prompt a user for their number grade and write a program and print out, according to Cassidy's scale, their letter grade. That's a little bit more complicated. The basics of the internal logic are right here, but you are going to have to get their input, and I'm going to give you a hint. You'll also have to use variable casting. So if you have any problems with that, if I'm there, raise your hand. We will take a look at it together. If not, write the question down. You can send me an email, and we will look at it the next time I am in class. So again, thank you very much for your attention. Good luck with the skills check. When you're done, upload it to my Cassidy. And the next video will cover a little bit more. The next video may cover a little bit more about Boolean operators. We may come back to these later.